lesson today. Are there any questions over the homework? Questions of the homework assignments?
It's one of the negative questions on the
Okay, which one? Do you have it? This one? Okay, we can. Do you want to look at it, or do you want me to do it on the board? Okay. All right, we're going to look at one of the homework problems on 3.1, number 17. So what it wants us to do is to factor this here. Now, the first step in factoring is to see if there's a greatest common factor. Now, a negative will be considered a greatest common factor, because this here, negative 3t squared plus 11t minus 6, doesn't have a numerical number that can go into all three terms, but we can factor the negative out, because we don't want that first term being negative. It's going to make things a little bit more difficult, or a little bit harder. So we'll first factor out the negative. And all that's going to do is change the signs for each term from positive to negative, or negative to positive. Now we'll have our two sets of parentheses with three spaces. And if we look at the sign, if the third term is positive, then the signs are the same and match the sign of the middle term. So here we'll have negative and negative. Now we're going to find the factors of the first term. Our factors of 3t squared. All right, guys, let's focus in. So we'll have t and t, since that's the only factors of t squared, and the only factors of 3 are 3 and 1. So we can plug those in. Now our factors of 6, 1 and 6 are 2 and 3. I'm going to try 2 and 3 first. So we just plug those in and check and see if we do get the correct middle term. 3t times negative 3 is going to be negative 9t. Negative 2 times t is going to be negative 2t. And negative 9t minus 2t is indeed negative 11t. So these here are our factors. Any other questions on the homework? You can, yes, because if we're good with homework. So what we're going to be looking at is completing the square. Completing the square, we did start this on Friday, and there are 4 main steps. The first step in completing the square is a equal to 1. If not, make it so. Step number 2 is to get the constant terms by themselves. So get the constant terms by themselves. Essentially, all that's saying is that the constant terms are on one side, our variables on the other, and leave 2 spaces. We're going to have 1 space on either side because we're going to add in our c. We're leaving room for c. Our third step is to find c. which is equal to b over 2 squared, and plug it in. Third step is to find c. Fourth step, factor the perfect square trinomial. Really, our x squared, our quadratic on the left-hand side is going, or our quadratic is going to be a perfect square trinomial. It's really just factor it and solve. Really, at that point, all we're doing is factoring and solving. And these are our four main steps. Now, if we can simplify our solutions, we're going to simplify them. If we can't, we'll leave them as a single equation with the plus or minus. Now, we've done one or two of these already. We've done one for sure of using the completing the square method to solve to find our solutions. And this is the first method that works on any and all quadratics. Okay. We get those written down. All right. Solve x squared minus 16x plus 64 equals 100. So we're going to solve this here. Now, we've already solved this. We've done this one before. This is one of the ones we did on Friday. And when we did this on Friday, the first thing we did was actually just factor this here. But for this, I think one of them might have been 4. I don't remember off the top of my head. But this one here, we're going to treat it and act like the x squared minus 16x plus 64 is not a perfect square trinomial already. So we're just going to go through these steps. First step, is a equal to 1? Yes, and when we talk about a, the a value is always going to be the number in front of x squared. Here the x squared is 1. So that means we can move on to step number 2. Get the constant terms by themselves and leave 2 spaces. So we need all the terms without variables on one side, so all of our numbers, and all of our terms with variables on the other. So the first thing we can do is subtract 64 from both sides. And then we're going to leave 2 spaces. So we subtract 64 from both sides, which on the left-hand side leaves us with our x squared, our 16x plus blank, equals, well, 100 minus 64 is 36, plus blank. We're leaving the spots to add back in the value of c. Questions on this so far? Step number 3 is to find the value of c. c is equal to b over 2 squared. And our b value, because again the general form is our ax squared plus bx plus c. b is the number in front of x, and it will indeed be 16, but it will be negative 16. because we have to take the sign with it. So it is 16, but since it is minus 16x, negative 16x, the value b is negative 16. It is indeed being squared. Now the first thing I would do is divide it by 2. 16 divided by 2 is negative 8. Then we can square it, and 16, or negative 8 squared is positive 64. Questions on this so far? Question? So far we've gotten the constant terms by itself. We found the value of c and we plugged it back in. Our next step is to factor the perfect square trinomial. All it's saying is this quadratic here, we're going to factor it. So we'll have a set of parentheses being squared, and we will have x, because with all these here, the number in front of that x squared is going to be 1. Now the number and sign that goes inside this parentheses is whatever the number and sign we had in finding c before we squared it. Since it's negative 8, we're going to plug negative 8 inside the parentheses here. Questions on this here? Equals 36 plus 64 is 100. Now since x squared minus 16x plus 64 was a perfect square trinomial to begin with, those first two steps really just undo each other. We get in the first 3 steps, we get back to where we started. All it just says we could have just factored it to begin with 2x minus 8 squared and not had to have done those previous steps. Now the last thing we have to do is solve, and we're really just solving by the square root method. So the next thing we can do is take the square root of both sides. So on the left-hand side, our square root and square will cancel, leaving us with x minus 8 is equal to plus or minus, because whenever we take the square root of both sides, we have to add the plus or minus. And the square root of 100 is 10. And last but not least, to solve for x, we will add 8 to both sides, telling us x is equal to, because the negative 8 plus 8 is 0, we have 8 plus or minus 10. Can we add 8 and 10? Yeah, as we can always grab the 30xs, the 8 plus 10 is 18. 8 minus 10, negative 2. If we can add and subtract these two, we need to add and subtract. We need to simplify. Because our 8 plus 10 is 18. Our 8 minus 10 is negative 2. If, when we take that square root of both sides, and the constant term does not simplify completely, we don't just get a number. If a radical or I, or square root of I, or the square root and I are left, we're not going to be able to combine them. They are not like terms. Questions on this here? We ready for the next one? Let's go on and move past that one. I want to look at one that's not starting off as a perfect square trinomial, so we can actually see how this works instead of just going back to where we were. So our first one is this here. X squared minus 4x plus 8 is equal to 0. Our first step, always going to be the same, is a equal to 1. Is the number in front of x squared 1? Yes. If not, make it so. Here we don't have to do anything to it because it is already 1. Our first main step is step number 2. First step, we actually have to do anything. Get the constant terms by themselves and leave 2 spaces. We want the variables on one side, constant terms on the other. And luckily for us here, x squared 4x only show up once on the left-hand side. So all we need to do is move our constant terms, the numbers without a variable, to the other side. If we subtract 8 from both sides, we do get x squared minus 4x. Plus, we leave one of our blanks there, equals negative 8 plus. And again, we leave 2 spaces so that we could plug in the value of c. We could plug that value back in on both sides to keep it equal and to get that perfect square trinomial. Questions on this so far? Next thing we need to do is find the value of c, which is equal to b over 2 squared. And our value b in this case would indeed be negative 4, because our b term is the number in front of x and its sign. So we have negative 4 over 2 squared. Negative 4 divided by 2 is negative 2. And negative 2 squared is 4. And the value of c is always going to be positive, because whenever we square a number, multiply a number by itself, it will be positive. Questions on steps 1, 2, or 3? We ready for step number 4? Step number 4, we want to factor the perfect square trinomial. We just want to factor this quadratic here. So we'll have a set of parentheses squared, and we will have x. The number and sign that goes inside this parenthesis will be the same as the number and sign inside the parentheses before we square it to find c. Since it was negative 2 inside the parentheses, we'll plug in the negative 2 there, giving us x minus 2 squared equals negative 8 plus 4 is negative 4. Questions on this here? Now at this point here, we do need to solve. So the next thing we can do is take the square root of both sides. And on the left-hand side, our square root and square will cancel, leaving us with x minus 2 is equal to plus or minus. Now we need to simplify the square root of negative 4. Now we can do this by seeing that since we have a negative inside the radical, it's going to come out as I, leaving us with the square root of 4. And the square root of 4 is indeed 2. Therefore, the square root of negative 4 is 2i. Questions on how we got to this point here? Plus minus. Questions on how we got to this point here? Last thing we need to do is solve for x, so we can add 2 to both sides. Telling us x is equal to 2 plus or minus 2i. Are 2 and 2i like terms? No. So can we add or subtract them? No. Questions on any of this here? We feel good with this here so far? Yes? All right. Let's look at the next one. X squared plus 8x minus 5 equals 0. Is A equal to 1? Is the number in front of x squared equal to 1? Well, yes. So, yes. We can move on to step number 2. Get the constant terms by themselves and leave 2 spaces. We want the constant terms on one side, our numbers without a variable on one side, and the numbers with a variable on the other. So we would add 5 to both sides. Which will give us x squared plus 8x plus our space equals 5 plus our space. Now, luckily, for the most part, these first few, we've just had to add or subtract a number from both sides. Sometimes that could mean that we need to do more than that. We need to move variables from side to side. Really, at this point, it doesn't matter how many steps it takes. We just need the x squared and x term on one side, or our variable squared and the variable on one side, numbers on the other. That's the entire setup we're trying to get at. Questions on how we get to this point here? Step number 3 is to find the value of c, which would be b over 2 squared. At this point here, we'd have positive 8 over 2. You're good? Because b over 2 squared, we could plug all that into the calculator, let it do it for us. But having that 8 divided by 2 and finding out that that's positive 4 helps us be able to factor this quadratic into our single set of parentheses squared. Because we do have x, but our number inside the parentheses and its sign go inside this parentheses here. It helps us be able to factor that down. So we do need that to be able to plug it in, but we also need the 16 so we know what we are adding to both sides. And 5 plus 16 is 21. No, fortunately not. Questions on how we got to x plus 4 squared equals 21. Understanding where we're at? Just kind of processing, thinking about it, yes? So we feel good getting here, yes? Now we square root both sides. And the nice thing is the left-hand side, the square root and square cancel. Plus or minus. We need to take the square root of 21. There is no exact square root of 21. And we leave it as the square root of 21. The 30xs is nice about this. But if we take the square root, it'll keep it in simplest radical form. We don't have to go through the whole factor tree or go through the prime factorization of 21 to see how it reduces. But here, it's just the square root of 21. Because if it gives you that number straight back, it doesn't reduce. It doesn't have to radical. Doesn't simplify down at all. Questions on how we got to this point here? Next step is to solve for x, and we do that by subtracting 4 from both sides. So x. So subtract 4. Now again, when we add or subtract, we want to put that number in front of the plus or minus. Since it's negative 4, we're subtracting 4. Negative 4. Negative 4 plus or minus the square root of 21. These are not like terms. The only way they would be is if I had negative 4 square roots of 21 plus or minus the square root of 21. Both of them have the same radical, same number. But here, that's as far as it goes. That's all we need for this here. Questions on any of this here so far? We're ready for the next one. Okay. Again, the big difference with this here and what we did with the square root method is getting to this set of parentheses squared. We feel good with this here. All right. 3x squared plus 12x plus 15 equals 0. So, is A equal to 1? No. This is the first one. All right, guys. Okay. So, A is not equal to 1. The number in front of x squared is not 1. If not, make it so. We have to divide by 3. Specifically, not just the 3x squared, but also the 12x, the 15, and the 0. We can't just divide one term by 3. We have to divide everything by 3. It is, I probably, right there. Yeah, I just scrolled down so we don't have the solve part. Yeah. Now, it's not directly stated, especially in any of the steps, but I would try to get all of our like terms together so we're not doing two different parts to it. So if there was x's on both sides or constant terms on both sides, x squared terms on both sides, I would get everything together, get it all on the same side before we start the process here. Now that a is equal to 1, we need to get the variables on one side, constant terms on the other. So we'll subtract 5 from both sides, which will tell us that we have x squared plus 4x plus blank equals negative 5 plus blank. Questions on this so far before we find the value of c? C is equal to b over 2 squared. Our b value in this case is positive 4. It's our number in front of x and its sign. Now the first thing we can do is divide it by 2. Well, 4 divided by 2 is 2. And 2 squared is 4. So we're going to add 4 into both sides, giving us x squared plus 4x plus 4 is equal to negative 5 plus 4. So, x, number and sign, yes, would be plus 2 because the number and sign in inside the parentheses before we squared it was 2. Now we take square root of both sides. So plus or minus. This actually just turns out to be I, because I, by definition, is the square root of negative 1. So it's just I. All right, guys, let's focus up here. Questions on how we got to this point here. Now the last thing we need to do is solve for x, and we can do that by at this point, if that number or term that came out of the square root has a square root left, I, or a square root and I, we're not going to be able to combine like terms. So this is our answer. But if that number that comes out of that radical simplifies completely and does not have I, we're going to have to combine those two terms. We have to add and subtract. Questions on this here? We're ready for the next one. Negative 3x squared minus 18x minus 6 equals 0. Now, A is not 1, and luckily everything is on the same side. Because if we had terms on the other side, it wouldn't equal to 0. It's going to be good to get all of our terms together, because here we are indeed going to have to divide everything by 3. But we're not going to have, we can't just divide by 3. It has to be negative 3. Because our first step in completing the square is A equal to 1. Specifically, we're talking about positive 1. We cannot have the number in front of x squared be negative. Because our negative 3x squared divided by negative 3 is going to be x squared. Negative 18x divided by negative 3. The negative and negative make a positive. 18 divided by 3 is 6. Negative 6 divided by negative 3 is going to be positive 2. So we need our variables on one side, our constant terms on the other, and exactly we'll subtract 2 from both sides. Get the constant terms on one side, variables on the other, and leave 2 spaces. That brings us to finding the value of c to make this a perfect square trinomial, which is going to get us to a point where we can solve this. C is equal to b over 2 squared. And b would indeed be positive 6. 6 divided by 2 is 3, and 3 squared is 9. So that does tell us what we're going to add to both sides. Now we will square root both sides. You get x plus 3 is equal to plus or minus. And exactly, the square root of 7 is just the square root of 7. If it does simplify, we would need to simplify it. So the square root of, say, 12 is 2 squares of 3. We need to simplify it to 2 squares of 3. And if you're not sure if it reduces or how it reduces, the 30xs will tell us. Because the square root of 7 is just the square root of 7. Square root of 12 is 2 square roots of 3. If it can reduce, we do need to reduce it. We subtract 3 from both sides. Because whenever we add or subtract that number, we do need to put it in front of the plus or minus. Since negative 3 and the square root of 7 are not like terms, we can't add or subtract. We can leave it here. You do not have to write this as two separate statements, as x equals negative 3 plus the square root of 7, and then write x is equal to negative 3 minus the square root of 7. We can just write it as a single expression. Questions on this here? Be good with this here. So do we feel comfortable with these here? Yes. Okay. Now I'm going to do one that's a little bit different. Okay. So if you want to cross that one out, you can, because we're going to look at this one here. Because as we've had up to this point, factoring works well as long as it's factorable. Graphing works well as long as the solutions are integers. We can find them easily. We can find rational, but it takes a little bit more work. Irrational are technically on there, but it takes a lot more work to find those. So graphing works well in some cases. Square root method works well in some. Completing the square makes it so that the square root method works well for the rest of them. Completing the square works great, and we could solve any of them by completing the square. But there are some that aren't as nice as others. So let's look at this here. A is not equal to 1. So we have to divide everything by 2. 2x squared divided by 2 is x squared minus 5 doesn't divide by 2 evenly. So we're going to leave it as negative 5 over 2. 67 does not divide by 2 evenly. So we leave it at 67 halves. Because as much as it would be nice, or as sometimes it's nicer to work with decimals, for these here, it's not as nice to work with decimals. So the completing the square works nice in a lot of cases, but here it's not as nice because now we're having to work with these fractions or decimals. But all the steps still work the same. It still works out the same way. We just are having to work with fractions now. Because our next step, get the constant terms by themselves and leave 2 spaces. So what we can do here is from both sides. And leave 2 spaces. Now our C term is still b over 2 squared. All right, guys. Stay focused. So our b value is negative 5 halves. So we have negative 5 halves over 2 squared. Now, I'm going to type this into the calculator. I'm not going to type the whole thing in. Specifically, we're going to type negative 5 halves over 2, which is negative 5 fourths. And we still have to square this. So when you say parentheses, negative 5 over 4, not 1, 4, squared is 25 over 16, 25 sixteenths. Questions on how we got to this point here? Yes. Because at this point here, we're factoring this perfect square trinomial and trying to come up with the factors of 25/16. Well, we don't have to. Because the number inside the parentheses before we square to find C is the number and sign, so number 5/4, since it's negative minus, that goes in this here. Here's 67/2. Gives us a nice number of negative 511/16. Okay. Questions on this so far? At this point here, we're going to square root both sides. Now the left-hand side is nice because our square root and square will cancel. So it tells us x minus 5/4 is equal to plus or minus we can take the square root of this. Now, a few things we can do. One, the negative is going to come out as I. Square is going to come out as I. Also, one thing that's nice, most likely, unless something interesting happens, we're going to have a radical. We're going to have, not radical, yes, we'll have a radical, but it's likely, but it will be rational. Because if squaring, or taking the square root of negative 511/16 would reduce, it should have reduced to begin with. Now, since we took the negative out, we do have 511/16. And we can't just plug in the square root of 511/16 all in the calculator like that. The 30xs needs it broken up. Yes. Second square root 511/2 square root. Well, what is the square root of 16? 4. So we could have done that without the calculator. Really, the main thing was finding the square root of 511. Well, it's actually just the square root of 511. And last but not least, we need to solve for x by adding 5/4 to both sides, which tells us those are not like terms because our 1 has a radical and I. Interesting thing with I is if it would just say the square root of 511, we put the I in front of the radical. But since it's fractional, we put it outside the radical and next to it. It's funny that works that way, but that is it there. Would we say that this one here made the problem or the process a lot harder? Yes, sir. Yeah. I mean, for the most part, we're using a calculator. It's not making it, I say, more difficult. It is more tedious keeping track of all of our fractions and making sure we're doing this right. But questions on this here? We ready for the next thing? Homework 25 through 28, 31, 32, 35, 38. 8 problems here. First 7, you're using completing the square to solve. Number 38, find the error. Find the error. Number 38 is specifically finding the error and finding the value of C. I will give you a hint. Make sure, just check the formula. It's a formula error that they have occurring. But that is the end of 3.5. We just have 3/6 left before our test.